Hello and welcome to my video, lesson 3.2 on reflections. So first of all, when we're just looking at the general form of this, we're going to talk about f of x, so y equals f of x. And then when we talk about the general form of the transformed function, we look at this whole thing. Now, specifically with reflections, we're looking at a and b, and we're going to look at those two for stretches as well. But right now, we're just looking at reflections, and reflections are when a is positive and negative, or when b is positive or negative. So if a or b is a negative value, it reflects the graph, the function, over either the y or the x value. So how can we remember what's going on? Whoops. So what we're going to do is notice, well, b is together with our x values, right? And so, because of that, it affects the x values. There will be an x value change. All right? On the other hand, a is closer to our y, or you can even think about y being replaced by y over a. Those are both perfectly valid options. X is also being replaced by b times x. So anyways, you can think about it either way, but either way that you look at it, the a value is changing the y values. So the y values will change, meaning that there's a reflection, however, in the x-axis. So this is a little bit confusing. The y values change, meaning it's an x-axis reflection, or the x values change, which means it's a y-axis reflection. So I think we're going to have to see some examples to be able to understand this a little bit more clearly. But it's the same concept as with translations. If it's near the x, it changes the x values. If it's near the y, it changes the y values. And that same idea is going to come up again in the next topic with stretches. So the parent function in this case is y equals x plus 2. So I'm going to just quickly draw this in here with black for my parent function. And let's see if I can just make the whole thing fit. Yes, perfect. So x plus 2, so it's going to be minus 2, so it's going to be here. And it's going to go, oh, do I have my ruler? I do have my ruler. I can make a straight line. Wonderful. Wonderful. Actually, I could even go and get a straight line like this. So there you go. Not too shabby. Okay, so that's our original equation. What's going to happen when we put the negative outside the brackets? Well, both are going to change, so let's just show what that looks like. Like that, right? Which means that it moves 2 to the right and goes the other direction. So now this goes, yep, perfect. And so now let's try the last one, which is going to hit the same spot, but go in the negative direction. So in this case, well, let's draw it out and then I'll show you what this looks like. Okay, so you can see both reflections. Okay, one where it reflects in the y-axis, right? The blue one here, it's reflecting in the y-axis. You can see that every single point has just been shifted over by that amount. Right? And you can look at it on the bottom as well. So it's pretty straightforward, right? And the other one is reflecting over the x-axis. So you can see now here, every point is the same. It's just reflected vertically. So the two different possibilities, they actually look kind of similar in this case. but one is being reflected in the x and one is being reflected in the y. So what's going on? Well, we just said that this one's being reflected in the x-axis, and this one is being reflected in the y-axis. I have found my mistake. So the problem is that I put the wrong graph in the wrong spot. Yeah, this is how it should be. So with all of that in mind, now it is labeled correctly. So the blue one is reflected in the x-axis, the red one is reflected in the y-axis. Okay, well, let's do another example, because that one may have been a little bit confusing because they look too similar. Let's look at ones that are maybe a little bit more different. So here we have a parent function y equals bracket x minus 2, so it's going to move to the right by 2 squared. So this is going to go to here, go to here, go to here, go to here. Okay, so the graph is going to look something like this. Roughly. That's the parent function. Now let's take a look at the other graphs. So if it is being reflected here in the x-axis, the y values are changing. So everything's the same except it's flipped on its head. So it will look like this. Opening downwards. Okay. The next one is reflected across the y-axis, which means that every point is going to be flipped. So this one stays the same, but this now flips onto this side, and so on. So it looks like this. Something like that. Okay, so you can see how it flipped over the y-axis. Okay, I didn't actually draw this out, but that's okay. I'll do it right now. All right, here is the original function. So what we're going to do is, in blue, we're going to reflect over the x-axis because the y values are being changed. So the y values are being changed, so that means every point is just going to be flipped vertically. So this first point is going to get flipped to there because it's 6 away from the x-axis. This one's going to get flipped to here. It's 3 away. This one's 2 away. This is going to stay where it is. And this is going to go here. So it's going to look something like this. That should be the axes should actually be touching each other, but it's not perfect. So it should go through this point, I think. And that one won't touch exactly. It'll be close enough. Okay. Awesome. Now what we're going to do is reflect f of x in the y-axis. So yeah, this is doing the opposite. So another way to show this is to show f of negative x. So reflecting over the y-axis means reflecting in the horizontal direction. So the top point reflects to there, This point is only 1 away. This point is 2 away. This point is 4 away. Oh, this point here is 7 away. Okay, like this. Okay, and you can hopefully see that it's reflected horizontally, flipping over the y-axis. All right, just doing practice problems like this is how you can learn. So I hope that this video helped you guys out a little bit, better understanding the idea of reflections in transformations, reflecting over the x-axis, y-axis, the a and b values, and which values are actually changing, the x or y values. Hope this video helped, and good luck.